Good afternoon, everyone. Welcome to today's Exploring by the Seat of Your Pants Hangout. My name is Joe Grabowski, and I will be your host for today. Those who've been following along this month, we've been celebrating space exploration. We've had all kinds of really exciting connections with scientists and explorers from around the world who are trying to make sense of this amazing universe that we do live in. And today we're continuing on with some more events. I'm really excited to be joined today by a scientist and engineer, Marc Rayman. He's been a space and astronomy enthusiast since he was 4 years old, and he knew by the fourth grade that he wanted to study physics, which is pretty cool. He currently works at the NASA's Jet Propulsion Laboratory on a bunch of really cool projects. So currently he's the chief engineer and mission director of Dawn, which is orbiting the dwarf planet Ceres. So Marc, not only does he get to study really amazing things in our solar system, he loves to share what he learns with the public as well. And he also likes other activities, including photography, hiking. He even has a black belt in karate. So Marc's a pretty multi-talented guy. So Marc, it's so great to have you joining us today. We're excited to learn more about you and what you do. And then, of course, I know our students are going to have a ton of questions.
Thanks, Joe. And hi, everybody. Thanks for joining in today. So I'm going to talk about space. I'm not going to do much about karate in this session. Maybe we'll have a different one on that. But as Joe said, I've been interested in space since I was 4 years old. And as he also said, when I was in the fourth grade, I decided I wanted to get a doctorate in physics and I wanted to work for NASA. But it was a few more years till I got to do both of those things. But I did them, and I'll tell you, I just love what I do. To me, it is so cool. And when I was younger than all of you, and throughout the time I was growing up, when I'd see people on TV working at NASA and things, I thought, that's what I want to do. And now that I get to do it, I still think it's cool. I mean, I'm an old man now, and yet I still have a great time. And in fact, a lot of times when I'm working here at JPL, I sort of take a step back and think, I am so lucky to get to do what I do. I just love it all the time. I would work here even if I didn't get paid for it. It's just, to me, it is so exciting. And I hope some of you get to have that same excitement, whether you go into space or some other kind of science or whatever field you go into, whatever you pursue. To me, you're so lucky if you get to do something that you really love, that you're just passionate about, and I am. And I hope you get to do that too. So I'm going to tell you a little bit about the work I do, but I guess I just want to tell you one more thing. That is, I said it was a few more years after my fourth grade decision of working for NASA. I actually was in school until I was 29 years old with no interruption except for some summer vacations. So it took quite a commitment, but to me, it was worth it because I loved learning new things, and I get to use all of the things I learned every day. And to me, that is really cool. So I'm going to share my screen with you and show you a little bit about what I've been doing here. And after we do that, then we'll see. Are you seeing my screen now?
Yeah, I see me, and it looks like you're pulling up the presentation. And we're full
screen.
The
presentation?
Yeah.
Okay. So just going to tell you about a few of the things I've been doing recently in space exploration, just to kind of give you a feel for some of what I've been lucky enough to do. And so the main spacecraft you see there is called Dawn. That's a spacecraft I've been working with for the last 11 years, actually. And I put below that another one that I worked on before called Deep Space One. Both of these missions to me have been really exciting. And Dawn explored these two bodies that are rotating there, Vesta and Ceres. And it's just been so fun to do this, and I want to show you a little bit more about it. But to start, I just wanted to sort of think about looking at the night sky. When I was growing up in Toledo, Ohio, I just loved to look at the stars. And, you know, a lot of times you don't have a nice clear night where you get to see the dark sky like this, but you know that that's what it looks like. And it's all these pinpoints of light. But, you know, if you just pick one out, I just picked one out in the center there, you know, it can be more than just a pinpoint. And in fact, that turns out to be Vesta, And here it is viewed by the powerful Hubble Space Telescope. But you can't really see a whole lot. It's kind of fuzzy. It's more than a pinpoint of light, but you can't really see that much because it's still very far away, even for the powerful space telescope called Hubble. So we sent a spacecraft there, and it turned it into this view. And to me, one of the things that's so cool about working at NASA is getting to explore an alien world like this. And so this is Vesta, which orbits the sun between Mars and Jupiter. It's the second largest body between Mars and Jupiter in the main asteroid belt. And my spacecraft went there in 2011, spent a year there orbiting it, taking all these pictures. Here you can see what we call the snowman of craters. Here you can see there's a network of canyons like this right here, more than 90 of these around the equator. These are larger in some cases than the Grand Canyon. These are huge things. And as we get down into the southern hemisphere, this is the wall of a crater that's 300 miles in diameter. And in the center of that crater, this is a mountain that's 110 miles across. And this mountain rises to more than 2.5 times the height of Mount Everest. Think about that. The planet you and I live on has nothing to compare with this. But this alien world called Vesta was unknown except as this faint smudge of light until my spacecraft got there a few years ago. And then after we left Vesta, we went on to orbit a dwarf planet called Ceres. That's where the spacecraft is right now. And here you can see Ceres. And it has, of course, as you can see, a lot of craters. It has some other things, these bright lines, some other lines here. But the main thing you notice is these bright areas like this. And this to me was one of the most amazing things that we've seen on this mission. So this crater here is 57 miles across. So I know you all live in different cities, but none of you lives in a city that's as big as this crater. And in fact, most of you live in a city that's only about this big. And yet, look, this whole area is just so bright. And when you see a thing like this, you just want to go in for a closer look and see what it is. And that's exactly what we did. And I'm going to show you some more pictures of this strange alien landscape here. But to do that, let me orient you again. So here's the crater. And notice there's another crater here at the top on the north side. So now let's look. So now we're looking north. There's that same crater. Here's these bright areas. And now as the Dawn spacecraft got closer, we were able to get in and get better views. And you can see here that there are mountains here. These mountains are thousands of feet high. And this bright material is down in a pit with canyons nearby. And Dawn got even closer. We've taken 100,000 pictures. Unfortunately, your teachers didn't give me enough time to show you each and every picture, so I'm just going to have to show you a few selected ones. So, for example, we zoomed in on this crater wall, and just look at the detail we could see there. I mean, this is an alien world farther away than the sun, farther than Mars. It's more than 300 million miles away. And yet we're able to get a spacecraft there close enough to see this crater wall with these huge blocks, huge boulders and ledges stuck on it. To me, it's a kind of landscape I'd love to go in my own spaceship with my own spacesuit and take a close-up look at this, and maybe you'll get to do that someday too. Here's another area in this bright spot. Look at this. So you can see this, it's strange. Why is it square? We actually don't know. And there's this long canyon here reaching out from it. And you can see some areas are brighter than others. We now understand that Ceres, this dwarf planet, it's in the same category as Pluto. Pluto was the second known dwarf planet. Ceres was the first, but it's not as famous today as Pluto is, but it was known 129 years before. Ceres has an underground ocean of salt water, but most of it's frozen. Sometimes it makes its way through canyons, through cracks in the ground like this, up to the surface. And when that water gets on the ground, it freezes and then sublimates. That means the solid water, the molecules in it, go elsewhere and leave behind the salt that was dissolved in it. And so what you're seeing here is salt left on the ground when the water basically evaporated. And the salt is very bright and reflective. And that's why it shows up like that. And we can zoom in still more so you can see this pit here and a mound just covered with this stuff. And this whole area here is miles across. Miles across. I mean, this is a big place. Now I'm going to flip around. We're looking from the south toward the north. Now we're looking from the north toward the south. And I want to show you on the top of this mountain, you can see this area here. And here's a close-up of this. What a strange looking feature here. And you can see this bright stuff looks like it just flowed down through cracks in the rocks. I think it's so exciting to be able to have a spacecraft there that can get a view that's thousands of times better than what we can get from Earth, even with the Hubble Space Telescope. And we can zoom out a little bit, take another look at one of these bright areas. Look how sharp the boundaries are between this bright stuff and the dark ground and the speckled pattern here. This is the kind of thing that here on Earth we don't see. And that to me is one of the things that's so neat about exploring alien worlds is you see sights, you see landscape, you see terrain, you see features and geological processes that are entirely different from what scientists can find here on Earth and elsewhere. You don't see things like this on the moon or Mars or other places that we've visited. And we can zoom out still some more and then back away even more. And this is a picture we just got in September, looking down on Ceres, reminding us again of how these bright areas just glow and capture your attention. I think they're really neat. But they're not the only neat things on Ceres, and so I want to show you a couple of others. This is a crater wall here. There's several miles, more than a mile high. Here's the crater floor, and I don't know whether you're close enough to see the display in your classroom, but you can see these trails here, like this and this. Here's another one here. This maybe is the most prominent. There's some up here and here. This is where huge boulders, very, very large, yards across, bounced and rolled down the crater wall, making an imprint in the ground at every place. Then you can see the boulder right at the end. This boulder fell down this crater wall, and you can see each place it hit the ground as it bounced. Here also, this one bounced and rolled to a stop right here. Here you can see another one. Its path crossed it. Here's still another one. Here's another one here. So there are boulders all over the place that just in recent times, this crater is 1 billion years old, but these boulders tumbled down the walls much more recently. And so a lot of times, you see these pictures on distant worlds and you think, boy, it's just not much is happening there, but it shows things do happen. And I think it would be so cool to be there in your spaceship and see one of these rocks tumbling for a mile or more down this wall, bouncing until it finally rolls to a stop. And here's a volcano that we found on Ceres. This volcano is more than 13,000 feet high. Some of the students participating today live in California. This is almost as high as the tallest mountains in California. And for the rest of you, you probably don't even have mountains this tall in your state. Here we are looking from within a crater nearby at this huge volcano. Now on Earth, volcanoes are made of hot lava, and maybe you've seen pictures of that. But Ceres is farther away from the sun, and it doesn't have as much heat inside as Earth does. And so on Ceres, everything is colder. And so this volcano didn't erupt with lava, but instead, on that cold world, it erupted with a mixture of water and rock and ice and salt, and it's sort of like mud. But on that distant world, that acts like lava does here on Earth. And Dawn's mission would be impossible, not just difficult, but impossible with conventional technology. You know, we just landed a spacecraft on Mars, and you're hearing from you've heard of other missions that go elsewhere in the solar system, but those missions would not be capable of going to Vesta and Ceres because it's just too hard to orbit two distant worlds unless you use ion propulsion, which I first heard of in Star Wars and Star Trek. And I hope you recognize the Star Wars TIE fighter here that Darth Vader and others used to fight the Rebel Alliance. And in the Star Wars universe, the TIE fighter, TIE, stands for Twin Ion Engine, because this was the most futuristic, coolest, advanced technology that they could think of. And to me, one of the rewards is turning that science fiction into science fact. And so here's Dawn using its ion engine flying into orbit around Ceres just a few years ago. And without this ion propulsion, this would have been impossible. And here's an ion engine operating here at JPL in Pasadena, California, where I am right now. And you can see it really does produce this cool blue glow like in science fiction movies. And the science fiction movies, they didn't make this up. They got the idea from the research that people at NASA had been doing on ion propulsion for a long time. And that's the key to what allows us to undertake a mission which would be impossible with conventional technology. Here's an artist's concept of the Dawn spacecraft firing up one of its ion engines. And this is how we traveled through the solar system. And thanks to this amazing capability, as the spacecraft propels itself on top of this long bluish greenish beam of xenon ions, this has allowed Dawn to accelerate to higher speed than any spacecraft in history has ever been able to do under its own power. So Dawn really has a unique capability with its ion propulsion to go places and do things that would not be possible without it. And I just think this is so fun, so cool to work on. But that's an artist's concept. Here's a photograph of Dawn when we were building it. This is one of those big solar array wings. And the solar arrays are so big because the spacecraft goes far from the sun. So the sunlight is weak. You need a large area of solar cells to catch enough sunlight to make the electrical power. But you can't fit that big spacecraft inside the nose cone of a rocket, and so we fold the arrays up before we launch. This is our main antenna. This is how we communicate with the spacecraft with radio signals. This is one of the ion engines. Here's another view. Here's the main spacecraft. These are our cameras and other scientific instruments. There's that antenna. Here's my friend Tom. Here's one of the solar array wings. Each solar array wing is the width of a tennis court. And from one wing tip all the way to the other at 65 feet, that's the distance from a pitcher's mound to home plate in a professional baseball field. When we launched Dawn, this was the largest interplanetary spacecraft NASA had ever sent into space. And launching it is a really exciting experience. We launched Dawn at dawn. In fact, you can see the sun rising in the background here. So that was a nice coincidence. We launched from Cape Canaveral in Florida, sent it out into space. And then when it got out into space, I told you about the solar rays. I'm going to show you a video. This is actually from a different mission I worked on, Deep Space One, but it did the same thing as Dawn. Gets up and it opens up these solar rays like an accordion. After the nose cone of the rocket separates, here it's leaving the moon and the Earth behind, points the solar rays at the sun to produce electrical power. We fire up that ion propulsion system, and then we travel through the solar system. And to me, there's just nothing cooler than being responsible for a spacecraft that's flying farther than the moon, farther than the sun, farther than Mars, deep into space. And now here it is, orbiting this dwarf planet between Mars and Jupiter. This is the orbit the spacecraft has been in, and in fact will be in for decades and probably centuries. So just a few weeks ago, in fact, on Halloween, as it turns out, the spacecraft exhausted its propellant, and it's now just going to stay in this orbit for probably hundreds of years, just orbiting Ceres silently, no longer able to point its antenna to Earth. But before it reached that fate, it sent us, as I told you, 100,000 pictures and all kinds of other measurements. And to me, it's really neat to think of our spacecraft from Earth just silently, calmly, serenely staying in orbit for the rest of my lifetime, for your lifetime, and the lifetime of your children and your grandchildren and your great-grandchildren for hundreds and hundreds of years. And so that's the Dawn mission. And let me take you back. Oh, go ahead.
I was going to say that's amazing. It's such cool projects you get to work on, and the detail they can send back from other worlds is pretty incredible.
It is. Are you back to seeing me?
We were for a second, but I think you might have hit the button again. If you hit the green button, it should bring you back to us. All right, we got you now.
Okay. So that's just a little bit of what I've been lucky enough to work on. And as I told you, I just think it is really, really fun. It's exciting. It's interesting. And to me, getting to do this is the reward for spending so much of my life in school, working hard, so I would be in a position to be able to do this. So anyway, again, that's just a little bit. And if any of you have any questions about either the missions I've worked on or anything else, I'll be happy to try to answer the question. If I can't, I'll tell you that.
All right, that sounds like a fair deal. Let's start meeting some of our live classrooms. We've got a great group of classrooms from across North America.
In fact, I think, if I'm not mistaken, you told me we have the best classrooms in North America just in this meeting today, right?
100%, no question.
Okay, good. Just wanted to make sure.
Yeah. Quick reminder, I know we have a few classrooms viewing on YouTube. If you have any questions, you can send them in via the YouTube chat sidebar. And of course, any classroom, whether you're on camera or watching on YouTube, send us in some pictures and make sure to share them to Exploring by the Seat of Your Pants via Twitter, and we'll post those out as well. All right, let's start off in Mrs. Moore's class. They are joining us from Sterling, Virginia. They're a grade 4 class. It's a big group of them, so I bet they're pretty loud. Let's find out. How are we doing, grade 4?
Hold on, let's turn off the microphone.
You're on, we can hear you.
Okay, great. All right, wave hi.
All right, who's got a question?
Come on. Quickly. Tell us who you are.
Hi.
Is that planet farther than Pluto?
Did you say, is it farther than Pluto?
Yeah.
That's a good question. It's not farther away than Pluto. So Pluto orbits the sun beyond Neptune most of the time. Sometimes it comes in a little bit closer than Neptune, but usually it's farther than Neptune. But Ceres orbits the sun between Mars and Jupiter. So it's not as far away. But it's still pretty far. Again, farther than Mars and hundreds of millions of miles away. but they're both called dwarf planets. And as I said, Ceres was discovered 129 years before Pluto. I think they're both neat places.
All right, awesome question to start us off.
It was.
Yeah, let's jump to another classroom. This time we're going to go to some third graders with Mr. Jancy. They are in Palo Alto, California. Let me turn their mic on and see how they're doing. How are we doing, California?
Yeah!
Pretty good.
Wow, I bet you could hear that all across the country.
It's Jancy. What are the asteroids appointed?
Yeah, why are the asteroids important?
I couldn't make that out.
Did you get that? They're wondering, why are they important? Why are these dwarf planets important?
That's a good question. They're important for several reasons. One is, by studying the different objects in the solar system, we can learn how the whole solar system works. You know, Earth is a part of the solar system, right? Our planet, the one that's right underneath our feet, is one of 8 planets that orbit the sun, and yet they're all different. Why are the planets different? And in fact, in some ways, they're similar. Many of them have atmospheres. Some of them, like Mercury and Venus and Mars, are rocky. Others, like Jupiter, Saturn, Uranus, and Neptune, have a lot of gas. Excuse me. Why are there similar? Why are some of them similar? Why are there differences? So scientists want to understand kind of the overall picture. How does the whole solar system work? How did it all fit together? And Vesta and Ceres are part of that. They're the 2 largest objects between Mars and Jupiter. And in fact, we now understand that Vesta, the first place that I showed you, is more closely related to planets like Earth than it is to asteroids. And yet Ceres, which is in the similar part of the solar system, is very different. It's not very much like the planets of the inner solar system. And so we want to understand all of them in order to put together the big picture of how the solar system works. And you can sort of understand this by thinking, if you wanted to know about life on Earth, you wouldn't just study one kind of animal, say giraffes, right? You wouldn't want to study even just all mammals, because then you'd be leaving out insects and fish, and you'd be leaving out plants and fungi. So scientists want to study sort of everything together in order to put together the big picture of how do things work. And that's why we study all of the different bodies in the solar system.
All right, great question and a great answer, Mark. Thank you.
But actually, can I just add one more thing?
Absolutely.
I'll tell you another reason to study them, and that is because it's so cool. I mean, look again at those neat things that we saw. Part of exploration is discovering things you don't know about, right? And so you go there to see, what new things do you find? And that's part of what's so rewarding about being able to explore, whether it's exploring bodies in the solar system, exploring deep under the ocean, exploring how the subatomic world works, all kinds of things. Exploration, I think it's really cool.
All right. We are going to jump now to Canada. We're going to go to Raymond, Alberta. We have some grade 6s joining us with Mrs. Bowles. Let me turn her microphone on. How are we doing, Alberta?
Whoa. Hi.
Hi. Can you see yourself down here? Yeah. Considering why you guys were like wearing the suits when you were like building the things, like
Those white suits that people. Yeah. That's another neat question. I'll tell you, we call those bunny suits because it makes people look like, yeah. But the reason we do it is because the spacecraft have a lot of small electronics in them, more sophisticated, smaller than the electronics in your computer or in a smartphone, things like that. And when the spacecraft gets out in space, of course, it's weightless. So any tiny particles of dust that are in it can float around in the zero gravity and get into those electronics and cause problems. Or they could move around in a camera, for example, and interfere with the camera's performance. And other electronics and other devices on the spacecraft could be very sensitive to that. So we don't want to risk getting even a particle of skin, some dust, a piece of hair, or anything like that. And so these white suits, these bunny suits, are made of special materials, unlike your shirt and mine, where lint can get on it and then could float off in the air and land on it. So before you go in those rooms, you take what's called an air shower. So you go in a room that blows air on you to try to get rid of a lot of the dust. Then you put these special suits on, and you put covers on your shoes, and you put the hat on. And for the men who have beards, they put a mask on to protect the spacecraft from our dirty sources of contamination.
All right, Alberta, very observant. Thank you for
Yeah.
Let's see. Let's go. I think this group with Mrs. Alexander, I think they're our group from Fallon, Nevada. Let me turn their microphone on and check. Hey, is this our group in Nevada?
Yep.
All right. Hey, boys and girls, who's got a question?
Going up to.
I want to ask a question. Oh, my name is Tyler, and
Hi.
I'm curious. What is the strangest thing you've seen in space?
Did you say what's the strangest thing I've seen in space?
Yep.
That's a good question. I've actually seen some pretty strange things in space, but I would say the strangest thing is those bright white areas that I showed you. So when Dawn was just approaching Ceres, when it was farther away from Ceres than the Earth is from the moon, these bright features started to show up. And to me, it was just so mesmerizing. It was almost like Ceres had a lighthouse on it, casting its light out into space, sort of inviting an interplanetary traveler to come in for a closer look. I don't know, it's just, to me, it was so cool to see that. And when we first saw it, it just looked like one bright spot, because we didn't have sharp enough pictures when we were far away to see the detail that I showed you today. And the closer we got, the more and more detail we could see, till at first it looked like one spot, then it was two, then it was this whole grouping of spots. Then we could see all kinds of detail on it. I just thought the mystery of what that was, getting to discover it and then solve it, I thought was really cool and really strange. I thought it was really weird.
All right, great question.
Yeah.
Let's see. Let's take a trip now to Burlington, Vermont. We have some grade 7 and 8s joining us with Mr. Caswell. Let me turn their microphone on. How are we doing, 7 8s?
Hey.
How many moons do they have if they have moons?
That's another great question. They don't have, so we didn't find moons there, but we didn't know before we got there whether they would have moons, because there are bodies in the solar system smaller than Vesta and Ceres that do have moons. So if this is Ceres, when the spacecraft flew in, we took pictures with our camera to look for moons as we got closer and closer, both around Vesta and around Ceres. We didn't find any. I don't know why. But when you think about it, look, Mars has 2 moons and Earth has 1. Venus doesn't have any. Mercury doesn't have any. So it's strange. We don't know why. But I'll tell you one more thing. Although we didn't discover any moons at Vesta and we didn't discover any moons at Ceres, I now know that Ceres does have a moon. Its name is Dawn. So our spacecraft made an artificial moon, and it's going to stay in orbit just as surely as our moon stays in orbit around the Earth and the Earth stays in orbit around the sun.
Very
but
cool.
No natural moons.
You left a little present behind.
Exactly.
All right.
A present from all humankind.
Very cool. Let's go to some grade 8s joining us in Sayreville, New Jersey with Mrs. Hawkenos. Let me turn their microphone on. I think I can reach it. Oh, maybe not. Mrs. Hawkenos, it's just off my screen if you don't mind turning it on for me.
Hello, my name is Vivian, and I was wondering,
Hi, Vivian.
how has being a part of this mission impacted your life? And if you were to do it again, would you do anything differently?
So I'm not sure I heard that. Let me say, did you say how did it affect my life? And if I could do it over again, how would I do it differently? Interesting question. So it affected my life in a really big way. I worked on this mission for 5 years to design and build the spacecraft with a tremendously large number of people. I didn't do it all by myself. It takes a lot of people to do this. So it was 5 years from the time I started working on it until we launched. And then 11 years, think of that, 11 years ago is when we launched it. It took that long to go from Earth, to fly past Mars, to go into orbit around Vesta, then to leave Vesta, travel another 2.5 years and 900 million miles to Ceres, and then to study Ceres. So this is a big part of my life. And it affected it because the whole time I was thinking, as I told you earlier, how cool is this? How lucky am I to get to do something so neat, so rewarding, so exciting? It was hard work. I mean, I worked 7 days a week, long hours. You know, sometimes you may have homework and you think, boy, there's a lot of work. Believe me, however much homework you've ever had, I had a lot more to make this mission work. But I felt so excited the whole time, seeing new things, solving new problems. To me, solving problems is fun. And, you know, you think about the pressure of a test in school. Think about what happens when the test is, solve this problem on the spacecraft or your mission will fail. That's a pretty high standard. That's to me maybe more pressure than whether you're going to get an A or a B or a C. So it affected my life because it was such a part of my life. To me, this was part of what made me who I am. So I don't know if that sort of answer makes sense or not. And as for what I would do differently, that's an interesting question. We have on the spacecraft some devices that we use to orient the spacecraft in the zero gravity of space. You know, here on Earth, you and I orient ourselves because, I don't know if you know about our inner ear, our vestibular system, but it helps you tell what direction is down. And when you turn, you can sort of sense it, right? Even if you were in a dark room, if you turned around, you would know that you were turning. Well, a spacecraft needs help to do that in the zero gravity of space. And so we had these devices on board and they failed, unfortunately. And a big part of the challenge of this mission, the reason it takes a lot of smart people to make it work, is even though these devices failed, we found a way around it, managed to save the spacecraft, even, again, when it was 3 times farther away than the sun, farther away than Mars. We were able to rescue this spacecraft from what could have been a fatal problem. But that was a lot of extra hard work that, although I'm very proud of my team for doing that, I wish we didn't have to do. So one thing I would have done differently would have been to put a different version of these same devices on board.
All right. Before we jump to our final live classroom, I just want to give a shout out to Holy Rosary in Waterloo. They're watching along, and this is their first live streaming event, so they're pretty excited to be joining in.
Well, I don't blame them. Welcome.
All right. Our last group is joining us. Where are they? There we go. From San Antonio, Texas. There's some high school students. Let me turn their microphone on.
But they're probably not as enthusiastic as any of the other classrooms.
I don't know. Let's find out. How we doing, Texas?
Yeah!
Not bad.
I guess I was wrong.
Who's got a question?
So we were wondering, how long does it take for the telescope to develop images and send them back to Earth?
Did you say how long does it take to develop the images and send them back?
Yes.
So developing the images, the spacecraft, of course, has cameras on it. And the camera works just like the camera in your computer or a smartphone. That is, it doesn't have to develop it. It just the picture is immediately available on board the spacecraft. But for the spacecraft to send a radio signal to Earth, it takes about 1 minute to transmit that picture. And then it takes that radio signal about half an hour to get from the spacecraft to Earth. It's that far away. Is that answering your question?
Yes.
So let me add something to that. Just think about it. When with the radio taking so long to travel between the spacecraft and Earth, that's because it travels at the speed of light, which is the fastest anything can go. When we send an instruction to the Dawn spacecraft, it takes half an hour to go from Earth across the solar system to Dawn, and then another half an hour for it to send a signal back to acknowledge that we got it. So, if you use your smartphone or a computer, when you touch a key on the computer or move your mouse, you see it on the screen right away, right? For us, this would be like it taking an hour from the time you move your mouse or click until you actually see it happen. So if you require instant gratification, then controlling interplanetary spacecraft isn't for you. But I think it's pretty cool to think about how far away these spacecraft are.
All right. Well, Mark, I wish we could just keep going with questions all afternoon, but unfortunately we're running low on time.
Okay.
There's a question from our class in Waterloo that's online. With the time we have left, maybe a minute or two, can you describe very simply how an ion engine works?
Sure. Let me quickly remind you how a regular engine works. You take a gas and you heat it up, or you put it under pressure and you push it out of a rocket nozzle. And so the action of the gas going out of the nozzle causes a reaction that pushes the spacecraft in the other direction. An ion engine works on the same principle, but we don't heat the gas up or put it under pressure. Instead, we give it a little electric charge. Some of you may know the word ion. An ion is just an atom that's electrically charged. And when it has an electric charge, it can feel the effect of a voltage. So we have two metal grids that we put very close together. They're separated by only about 10 times the thickness of your hair, or 20 times the thickness of my hair. We put more than 1,000 volts between them and shoot these ions out of the engine at 90,000 miles per hour. And the action of an ion going out at 90,000 miles per hour causes a reaction that pushes the spacecraft in the other direction. And because it goes out so fast, it gives a large push the other way, and that's what makes the engine work. I know that was quick. I hope it made sense, but I was trying to keep within the time limit here.
Absolutely. Well, Mark, first of all, I want to say a huge thank you to our classrooms who joined us from across North America today. As per usual, you guys were awesome. Your questions were amazing. Mark, thank you so much for taking some time from your busy day to work with us and to share your passion for space exploration. I know it definitely rubbed off on a lot of students today. So thank you so much for hanging out with us today.
You're welcome. Thank you for setting up. And let me thank all of you students for connecting, and thank your teachers. I appreciate all the teachers arranging this. It was fun to talk to you. I was glad to get to see all of you. And I hope some of you decide to pursue a career in space exploration or in science. And I'll just mention quickly, even for people who want to get involved in it, if science and math don't work for you, it takes a lot of different kinds of talents to do this. At a place like JPL, we have lawyers, we have business people, we have managers, we have people that worry about take care of financial contracts, we have our own police department and fire department. We have all kinds of things. So there are a lot of different ways to get involved in cool fields. But anyway, thanks everybody for joining in. It was fun to talk to you.
All right, last thing we'll do, all the classrooms were loud separately. I'm going to turn all the mics on and see how loud they can be together. So big goodbye and thank you for Mark. Here we go. Microphones are on. Thank you.